So welcome to iLearn Review Day 8. Today we're going to take a look at probability. We're going to start by taking a look at mutually exclusive events, and what that means is they cannot happen at the same time. So mutually exclusive means cannot happen at the same time. And it says, for this question, for number 70, it says, which statement describes a mutually exclusive event? Circle all that apply. So if we think about A, it says, flip a coin, it lands on heads, it lands on tails. Can you flip a coin and it land on both heads and tails at the exact same time? You cannot. So that means that that is a mutually exclusive. So A is a mutually exclusive event. It cannot happen at the exact same time. You run a race against three people. You finish first, you finish third. So if you're running a race, you're either going to finish first or you're going to finish third. You cannot finish first and third at the same time. So B is also a mutually exclusive event. Drawing a playing card from a deck. The card is red. The card is 5. That can happen at the same time, so that is not a mutually exclusive event. You could draw a 5 of hearts or you could draw a 5 of diamonds. Rolling a single dice and getting an even number and getting a 4. That can happen. So you can roll and get the number 4. That's 4 is an even number. So mutually exclusive means that it cannot happen at the same time. And so A and B only fit that definition. For problems number 71 and 72 and 73, we want to look at what the compound probability of each event is. And then once we figure that out, we want to figure out if the event is independent or dependent. And so the first thing you have to do is you have to know what the simple probability is of each event happening. So for example, when we look at rolling a 6-sided die twice and getting an even number both times. So first of all, we can get an even number 3 times out of 6 rolls, because we could get 2, 4, or 6, and there's 6 sides to the dice. If we do that twice, it's still 3 out of 6. And so when we look at finding the probability of an event, we're going to multiply them together. And so 3 times 3 is 9, and 6 times 6 is 36. We want to reduce that. Both these numbers are divisible by 9, so 9 divided by 9 is 1, and 36 divided by 9 is 4. So 1 out of every 4 times, you're going to get an even number 2 times in a row. Now we have to determine, is this event independent or dependent? So the probability was 3 out of 6 for the first event. The second event was still 3 out of 6. The event didn't change. So that means that it's independent. And you'll see what I'm talking about here in a second. If we look at number 72, it says John has 2 nickels, 6 pennies in his pocket. If he took out 1 coin and then a second without replacing the first coin, what is the probability both coins are pennies? And so we look at this and we say, okay, well, there's 6 pennies out of 8 the first time. Well, if I take a penny out the first time, there's now only 5 pennies. In addition to that, there's also only a total of 7 coins. And so notice how the first event changed the probability of the second event. And so for this reason, that is called dependent. And we'll figure out what the probability is. First of all, you can reduce 6 over 8 to 1/4. So if we to 3/4. If we go ahead and reduce that and we multiply those together, 3 times 5 is 15. And 4 times 7 is 28. So 15 out of 28 times, we'll get a penny both times. Now, flipping a coin 3 times and having it land on tails all 3 times. Well, first of all, there's 1 tails, and there's 2 possible choices, heads or tails. And if we flip it again, there's still only one tails. There's still two possible choices. And we flip it again, one tails, still only two possible choices. And so you'll notice how 1/2, 1/2, 1/2, nothing changed. So that means that this is a independent. The events are all independent of each other. So 1 times 1 times 1 is simply 1. But 2 times 2 times 2 is 8. Now, looking at number 74, it says, we're going to talk about combinations, how many different combinations you can make. It says you need to create a 6-character passcode. The first 3 characters must be lowercase letters A through Z. And the last 3 characters must be the numbers 0 through 9. If the characters cannot repeat, how many different passcodes could you make? Well, there's 26 letters in the alphabet. But if I can't reuse one of them, that means the next space I only have 25 letters to choose from. And the next space I only have 24 letters to choose from. Now, 0 through 9 is 10 possible characters you could use. And then if I can't reuse them, there's only 9 the next time. If I can't reuse them, there's only 8. And so once you know how many possible characters you could use for each individual space, you're just going to go through and you're going to multiply them all together. And absolutely use a calculator for this. We want to make sure we use Desmos scientific calculator. And so our calculator said 26 times 25 times 24 times 10 times 9 times 8. And so there are 11,232,000 different combinations you can make. So this is going to be equal to 1, 1, 2, 3, 2, 1, 2, 3 zeros. And this is how many different combinations you can make. Now, looking at number 75, it says you need to create a 6-character passcode. With the first 3 characters must be lowercase, so the same thing. 1, 2, 3. They have to be A through Z. And then the last 3 can be 0 through 9. But this time they can repeat. So how many different passcodes could you make? Well, you have 26 letters to choose from, 26 letters to choose from, 26 letters to choose from, 10 letters to choose from, or 10 numbers, and 10 numbers to choose from. Again, go to your calculator. You're simply going to do 26 times 26 times 26 times 10 times 10 times 10. And you're going to get 17,576,000. So 17 million. So this is going to be equal to 17576, 0, 0, 0. Double check your calculator, make sure you typed it in correct. I did. We're good. So for the second character passwords, we could have 17,576,000 different combinations. That completes today's iLearn review. Tomorrow we will take a look at the exponent rules and determine whether or not what you do with those exponents when you're multiplying, dividing, or power to power, or if you have a negative exponent. So we'll look at problems 76 through 91 tomorrow.